Welcome back to the SQL Professor. If you're new here, welcome. What we do here is give you the tools that you need to succeed as a database programmer or administrator. I draw on my 20 years in IT and nearly 10 as an IT professor to package up SQL skills and concepts you can put to use today. In this video, we are going to cover a few examples of advanced Windows functions. I'm going to presume that you already know what a Windows function is. What I want to do is show you a little bit of the advanced features and how they're used. And really, this is where a lot of SQL starts to cross the line into data analytics and really some data mining. Here I am in SQL Server. We're going to create a sales by date table. It's pretty straightforward, just an identity column, the date of the sale, and the number of sales. And you can see here, once we start inputting the data, there's multiple rows per day. Perhaps this is different locations, different time periods, however you want to think of it. It's really just there's 5 rows for July 1st, 3 rows for July 2nd. So I'll create this table, and then I will insert my data. We have a total of 10 days. Come down here. So if I go ahead and select, you'll see 5 days for July 1st, 3 for July 2nd, another 5, 6 or so for July 3rd. What I want to show you is the difference between range and rows for the overstatement in a Windows function. So you can see here sales date, number of sales, the sum. Over, we want to order by the sales date, rows between unbounded preceding and current row as running total. So this should go all the way back to the beginning of our window and just sum up each row. Same exact statement for the second one, except I have this range between unbounded preceding and current row as running total. And it's simplest to just show you the results. So if I run these two side by side, the first one is maybe what you may expect. Over the course of July 1st, 64 total. Starts out with 12, adds 8 to get to 20, adds 15 to get to 35, all the way up to 64. Then we're up to 83 total sales at the end of the 90 at the end of the second by adding 5 and then 14 and then 7 all the way to the 10th with the final 9 sales getting up to 444 total. And that's the rows function. That's what you see most of the time. Range gives you the same answer ultimately, but packaged a little bit differently. And you can see here July 1st, 12, but the running total is the total for July 1st. It's the window is based on the order by the range, everything in that window that matches the order by, so July 1st. So the sum will give you the total by day. So you can see 12 out of a total of 64 after day 1. And then 90, but you see it doesn't increment by 5 and then by 14 and then by 7. It increments by the total 26. And then you have the total after day 2 is present on all the rows for July 2nd. July 3rd, all of these together, these 67 sales, present a total for the after 3 days of 157. Same data, so you ultimately get to 444 rows, but it's packaging your running total by day. So after day 10, this is the total, even though we have our 2 rows for day 10. After 9 days, there's 423, even though we have these 4 rows. You don't see range too often in SQL Server. As of SQL Server 2022, the unbounded preceding and current row are really the only options available for range. You can't, for example, have the last 3 rows and up to current row to have that sliding window effect. It's just not really supported. And it kind of makes sense, unbounded preceding for this range. Well, if you had the last 3, well, what does that mean? The last 3 but not the 4th for the July 9th? So it does clean it up. You can see how this might be useful if you wanted to see what was the total at the end of a day that is present on all of the rows. You don't have to figure out what the last row was to get to 157 like you do up here. To get to the 157, it only gets there after that last 10 sales have been added. So a little bit of a difference between range and rows. You'll see them both. Rows maybe is a little bit more intuitive, especially for a running total, but range has its purpose. I mentioned sliding windows. Let's go ahead and see some examples there. First, I'm going to create a batting table. Pretty straightforward, has a key, a name, the season they played in, and some stats: runs, at-bats, games at-bats, runs, hits, doubles, triples, and so on. And then I'm going to insert data. For 4 years, for the most part, for 10 players. The one I will point out, or 2 I will point out, Starling here has no playing time in 2023, and then Freddie here has no playing time in 2022. We'll see how those come together. So we've inserted. You can see most have 4 rows. The 2 exceptions have 3 that I pointed out. First way to look at this is the last 3 seasons, kind of a moving average. So the average over partition by the player, order by the season, rows between. Again, this is something where range does not offer this ability to put an integer here. 2 preceding and the current row. So it will come up with a moving average of home runs per playing season. Aaron Judge, the end of the first year, an average of 39, of course. Average after the second year of 50. There's 101 here, divided by 2, round it, 50 home runs. Dipped off a little bit. The average for 3 years is 48. And then the average for the 4th year is 54. If we look at Freddie, same concept here. It doesn't really distinguish or matter, but it is, you have to know your data. So the fact that there is no season 2022, or for Sterling, no season 2023, it's still computing the 3-year moving average. Another example, lag. So go back 1 and partition by player name, order by the season year, and then I'm going to subtract that from the current year home run. So this gives me last year's home runs. And then I can see the change year over year. 39 plus 23 minus 19 plus 15. Another player, 33 home runs, added 5, dropped off by 7, and then added another 2. Rank is another Windows function. Again, partitioning by year this time, order by the number of home runs. 2021, you can see the top 10 home run hitters, starting with 48 for Vladimir and Salvador, all the way down to 5 for Starling. 2022, top 9 because there is no data for one of the players in 2022. Aaron Judge ranked first. 2023. Again, only 9. First, second, third, all the way down to 9. And 54, 58 for Aaron Judge, 2024, and it runs from there. Very simple to create a rank automatically divided up by season. One last example, the so-called gap identification. So this uses a CTE. If I internally select the CTE here and show you what it has. We have Aaron Judge for his 4 seasons, number of home runs, and then the first year, or the minimum, within the group. So if you played for all 4 seasons, this will roll back to 2020, and you'll be just fine. For Freddie, you can see here the 1 year, and then with the gap, there's no 2022, and then the 2023 season, you can see the grouping goes only back for 2 years, and then it is consistent. This command will allow us to identify the gap in Freddie's service, as well as Starling here, with a gap between 2022 and 2024. When I run this, in fact, we can see 4 years of a streak when we have all of the data. Starling had a 1 year and then a 2 year streak. Freddie had a 1 year and a 2 year. If I run this without the halving clause, we'll get more than 10 rows. We'll get 12. We can see Starling here and here. And this could be used to help identify gaps in your data. We can have the halving, when the halving count is, not equal to 4. And I know I have a problem here, or at least a gap in my data. Very quick, leveraging the row number Windows function. So that about does it for this video. Windows functions, of course, very powerful. A little bit confusing at first, but they bridge that gap, like I mentioned, between SQL programming and data analytics. You can do a lot with them. They are an incredibly powerful tool to have in your toolkit. And hopefully this Windows function video gives you some food for thought and some ways that you might be able to use them against your own data set. If you have any questions, drop a comment. I appreciate your time, and I'll see you in the next video. Thanks.